Hello there, and welcome to Somnus Sagas, where the whispers of deep time weave stories to cradle your dreams. Tonight, we're not drifting beneath stars or sailing across seas, but standing on the edge of a molten world, where fire beneath the earth has sculpted the mountains, plains, and the very air you breathe. Volcanoes, those ancient titans, don't just erupt with flame and ash. They sing across eons, crafting continents, breathing life, and rewriting the planet's tale in rivers of lava. So as you ease into this quiet night, let me ask you something. Where are you resting now? Is there a hill nearby? A valley, a distant ridge? Could the ground beneath you pulse with the memory of a fire that burned millions of years ago? Volcanoes are the earth's poets, etching their verses in stone and sky. But how did their fury shape the world we know? How did their fire kindle life itself? If this journey through the planet's fiery past feels like a soothing path to slumber, I'd be so grateful if you'd like this video or subscribe to Somnus Sagas. It helps this haven of wonder find others who seek the calm of ancient tales. So settle in, let your thoughts drift, and let's begin. Because long before humans climbed peaks or named their slopes, Earth was already humming with the rhythm of its molten heart. And that rhythm forged everything. The fire before time 4 billion years ago. Earth was a newborn world, a cauldron of molten rock still cooling from its violent birth. No continent stood firm, no oceans lapped at shores, just a churning, glowing surface pocked with craters and alive with fire. Volcanoes weren't just features. They were the planet itself, exhaling gases, spewing lava, and laying the foundations for everything to come. Imagine it, a sky choked with steam, a moon too close, too raw, torn from Earth's side in a cosmic collision. And in that chaos, volcanoes were the first storytellers, their eruptions writing the opening lines of Earth's saga. Where did this fire come from? Deep within, where the planet's core, hotter than the sun's surface, churns with liquid iron, and the mantle above it flows like sluggish honey. This heat, born from Earth's formation and fueled by the slow decay of radioactive elements like uranium, drives the planet's pulse. Volcanoes are its breath, venting heat, gases, and molten rock to the surface. They don't just erupt, they create. In the Hadean Eon, over 4 billion years ago, volcanic outgassing released water vapor, carbon dioxide, and nitrogen, forming the first wisps of an atmosphere. Water condensed, rain for millennia, and pooled into the earliest oceans. Those oceans, acidic and dark, were cradled by volcanic landscapes, basalt plains and steaming vents where the first sparks of life may have flickered. These early volcanoes didn't just build the air and seas. They sculpted the crust itself. As lava cooled, it formed the first proto-continents, small, fragile islands of granite amidst a sea of molten stone. These were the seeds of the continents we know, forged in fire, eroded by water and pressed together by the restless mantle below. The earth was a canvas, and volcanoes held the brush. But this wasn't a gentle process. Picture a world where eruptions never ceased, where lava rivers carved valleys, and ash clouds darkened the skies. Yet, from this violence came possibility. Volcanoes delivered minerals to the surface, phosphorus, sulfur, iron, that will become the building blocks of life. In the Archean Eon, around 3.8 billion years ago, microbes emerged in the warm, mineral-rich waters near volcanic vents. These tiny pioneers, feeding on chemical energy, began to reshape the planet. Some learned to photosynthesize, exhaling oxygen into an atmosphere that couldn't yet hold it. This was the prelude to the Great Oxygenation Event, a revolution that began with volcanic gifts and ended with a new world. The Great Oxygenation, fire, and breath around 2.4 billion years ago, something extraordinary happened. Cyanobacteria, thriving in shallow seas warmed by volcanic heat, began to produce oxygen in vast quantities. This wasn't just a chemical shift, it was a planetary upheaval. Oxygen was poison to most early life, but a gift to the future. It rusted the iron dissolved in oceans, forming vast banded iron formations, stripes of red and grey that we mine today, a record of Earth's first deep breath. Volcanoes played their part, supplying the iron and nutrients that fueled these microbial blooms. The atmosphere thickened with oxygen, the seas cleared, and the stage was set for complexity. But this change wasn't gentle. The Great Oxygenation Event triggered a crisis. Anaerobic microbes unable to tolerate oxygen retreated or perished. The planet cooled, possibly because methane, a potent greenhouse gas, was oxidized away. Some scientists believe this sparked the first snowball Earth episodes, when glaciers stretched to the equator, locking oceans under ice. Yet, volcanoes never stopped. Their eruptions released carbon dioxide, warming the planet and melting the ice over millions of years. Life survived in volcanic refuges, hydrothermal vents and warm springs, where heat and chemistry sustained it through the freeze. This pattern, disruption followed by recovery, became Earth's rhythm. Volcanoes, with their fire and ash, were both destroyers and creators. They triggered crises but also provided the raw materials for renewal. As the Proterozoic Eon unfolded, continents grew larger, stitched together by volcanic arcs and tectonic collisions. Supercontinents like Columbia and Rodinia formed, their assembly driven by the same mantle heat that fueled volcanoes. When Rodinia broke apart around 750 million years ago, volcanic rifts opened, flooding the crust with lava and creating new ocean basins. These rifts reshaped climates, redirected currents, and set the stage for the Cambrian explosion, when life diversified with astonishing speed. The Cambrian explosion, fire's nurseries, Around 540 million years ago, the oceans erupted with life. Trilobites, brachiopods, creatures with eyes and jaws, all appearing in a geological blink. Why? Volcanoes played a crucial role. The breakup of Rodinia created shallow seas, rich with volcanic nutrients like phosphorus and calcium. These epicontinental seas, warmed by volcanic heat, became nurseries for early animals. Volcanic ash, rich in minerals, fertilized the waters, fueling plankton blooms that fed complex food chains. The continents, shaped by volcanic rifts, provided new coastlines where life could experiment and thrive. But volcanoes didn't just nurture, they also challenged. Their eruptions could choke seas with ash or acidify waters with sulfur. During the Paleozoic, as continents gathered into the supercontinent Pannotia, volcanic activity intensified. This set the stage for the first of the Big Five mass extinctions, the Ordovician-Silurian extinction, 444 million years ago. Volcanic eruptions, possibly coupled with glaciation, disrupted ocean chemistry. Sea levels fell, habitats shrank, and oxygen levels dropped, wiping out 85% of marine species. Yet, life recovered, guided by volcanic fertility. New reefs formed, new species evolved, and the continents bore the scars, folded rocks and ash layers that tell this story today. The Great Dying, fire's darkest hour, the most devastating chapter came 250 million years ago, during the Permian-Triassic extinction, known as the Great Dying. Beneath what is now Siberia, a massive mantle plume erupted, creating the Siberian Traps, a volcanic province that poured lava over an area the size of Europe for nearly 1 million years. This wasn't a single eruption, but a relentless outpouring, forming layers of basalt we call traps, from the Swedish word for stairs. The consequences were catastrophic. The eruptions released vast amounts of carbon dioxide and methane, warming the planet by up to 10 degrees C. Oceans acidified, losing oxygen in what scientists call oceanic anoxic events. Reefs dissolved, shellfish perished, and 96% of marine species vanished. On land, forests burned, soils eroded, and 70% of terrestrial life disappeared. Toxic gases like sulfur and chlorine, released as magma intruded into coal and salt deposits, triggered acid rain, poisoning ecosystems. The oceans, once life's cradle, became a graveyard. This wasn't just a volcanic event, it was a chain reaction. Warming oceans stratified, preventing oxygen from reaching the depths. Anaerobic bacteria thrived, producing hydrogen sulfide that poisoned the seas and atmosphere, damaging the ozone layer. The continents, reshaped by heat and uplift, bore witness to this collapse. Yet even in this darkness, volcanoes sowed the seeds of recovery. Their ash-enriched soils, their minerals fed surviving microbes, and over millions of years, life rebuilt. New corals appeared, early dinosaurs emerged, and the continents, now drifting apart, hosted new ecosystems. Pangaea's breakup, fire and drift. By the Mesozoic era, the continents had gathered into the supercontinent Pangaea, surrounded by the vast ocean Panthalassa. Volcanoes, driven by mantle plumes, were restless. Around 200 million years ago, Pangaea began to fracture. Massive volcanic eruptions, known as the Central Atlantic Magmatic Province, poured lava across what is now North America, South America, and Africa. These rifts opened the Atlantic Ocean, a process still ongoing at the Mid-Atlantic Ridge, where magma rises and cools, pushing continents apart at the pace of growing fingernails. This breakup wasn't just geological, it reshaped life. As continents drifted, new coastlines formed, isolating populations. Dinosaurs diversified, plants spread, and ocean currents shifted, altering climates. The Atlantic's birth created warm, shallow seas where marine reptiles like ichthyosaurs thrived. Volcanic islands, like those forming Hawaii today, rose as stepping stones for life, hosting unique species. But the fire wasn't done. At the end of the Cretaceous, 66 million years ago, another catastrophe struck. An asteroid hit the Yucatan Peninsula, releasing energy equivalent to billions of atomic bombs. Simultaneously, the Deccan Traps in India erupted, spewing lava and gases for thousands of years. The combined effect, darkened skies, acidified oceans, and a cooling planet, ended the dinosaurs' reign. Yet volcanoes also aided recovery, fertilizing oceans with nutrients that fueled plankton blooms, rebuilding food chains. The Cenozoic, fire's legacy. In the Cenozoic era, the age of mammals, volcanoes continued to shape the world. The Andes formed as the Pacific plate subducted beneath South America, lifting peaks and redirecting rivers. The Himalayas rose as India collided with Asia, closing the Tethys Sea and altering monsoons. Volcanic islands like Iceland and the Galapagos became laboratories for evolution, hosting species found nowhere else. The closing of the Central American Seaway 5 million years ago, driven by volcanic uplift, separated the Pacific and Atlantic, strengthening the Gulf Stream and triggering ice ages in the Northern Hemisphere. Volcanoes also influence climate. Their eruptions injected sulfate aerosols into the stratosphere, reflecting sunlight and causing temporary cooling. During the Eocene, 50 million years ago, high volcanic activity contributed to a greenhouse world, with palm trees near the poles. But as continents drifted and volcanoes quieted, Antarctica's isolation created the Antarctic Circumpolar Current, cooling the planet and ushering in the age of ice. Human discovery. Reading the Fire, the story of volcanoes isn't just written in stone. It's told by those who learn to read it. In 79 CE, Pliny the Younger documented Vesuvius's eruption, a moment that sparked early questions about Earth's fire. In the 18th century, James Hutton saw in Scotland's rocks a planet in motion, proposing deep time with no vestige of a beginning, no prospect of an end. Charles Lyell built on this, arguing that slow processes like volcanic eruptions shape the world. In 1912, Alfred Wegener's continental drift theory hinted at volcanic forces driving plate motion, though he lacked a mechanism. The 20th century brought clarity. Harry Hess's seafloor spreading theory, inspired by volcanic ridges, showed how magma drives tectonic plates. The discovery of magnetic stripes on the ocean floor, formed by volcanic basalt, confirmed plate tectonics. Deep-sea drilling, like the International Ocean Discovery Program, revealed ash layers and microfossils, linking volcanic eruptions to climate shifts and extinctions. Satellites like Topek's Poseidon mapped volcanic topography, while the Argo program tracked ocean changes influenced by volcanic heat. Submersibles like Alvin explored hydrothermal vents, discovering life thriving in volcanic darkness, hinting at possibilities on moons like Europa. The Anthropocene, fire and responsibility. Today, we live in the Anthropocene, where human actions rival volcanic forces. Burning fossil fuels, ancient carbon from volcanic-fed swamps, releases CO2 faster than any eruption since the PETM, 56 million years ago. The atmosphere warms, oceans acidify, and species migrate or vanish. Yet volcanoes remind us of Earth's resilience. After every eruption, life returns. Ash fertilizes soils, islands rise, and ecosystems adapt. The question is whether we can learn from this cycle. We have tools our ancestors lacked: satellites, models, isotopic clocks. We know CO2 levels are rising 100 times faster than during past warmings. We see coral reefs bleaching, glaciers melting, and storms intensifying. But we also see potential. Renewable energy, reforestation, and conservation can slow the chain reaction. Volcanoes teach us that disruption is inevitable, but recovery is possible if we act with foresight. The long recovery after every volcanic upheaval, Earth rebuilds. Post-Permian, it took 10 million years for reefs to return. After the Cretaceous, mammals filled dinosaur niches, fueled by volcanic nutrients. Recovery isn't a return to the past, it's a reinvention. Today, we're writing the next chapter. Will future geologists find a layer of microplastics and carbon spikes, or signs of stabilization? Forests regrowing, reefs rebuilding? The choice is ours. Volcanoes, like oceans, are Earth's memory. Their ash layers, lava flows, and isotopic signatures record every eruption, every extinction, every rebirth. They've built mountains, islands, and atmospheres, sculpted by fire and time. As you listen, the ground beneath you moves, millimeter by millimeter, driven by the same heat that sparked the first volcanoes. The earth is alive, its fire still burning, its story still unfolding. And so, as we return to the hush of your night, pause for a moment, feel the air, the ground, the quiet. Somewhere, a volcano breathes, its heat shaping the world as it always has. You're woven into this saga, standing on land born of fire, breathing air it crafted, dreaming beneath its ancient glow. If this journey through Earth's fiery heart has stirred something in you, a spark of wonder, a moment of peace, share it with us. Your thoughts, your questions, your favorite mountain or island born of flame. I read them all here at Somnus Sagas. If you'd like to wander these tales again, consider liking, subscribing, or joining us for the next saga. And if you're still awake, that's okay. Perhaps your mind lingers on a glowing ridge, watching the planet dream under a starlit sky. Next time you see a peak or feel the earth's faint tremble, know it's a verse from deep time, calling you to listen. Thank you for being here with Somnus Sagas. Sleep deeply and keep dreaming.